In this video clip, we will run WaveApps, which is the benchmarking application from VariWave. We're going to go through a simple setup just to show you how to get started running the application. We'll start by double-clicking on WaveApps, the icon. We'll maximize the screen here. So you can see a good example of how you might set your system under test and connect it up to the chassis. Now, from previous videos, we already showed the example of connecting the WBW2000 MIMO blade properly to an access point, and we're going to assume you've watched that and you already know how that connection is done. We're going to run a throughput test, which is one of many different benchmark tests that are available in the suite. As you set up any one of these tests, many of the things that you are setting up about the clients and the ports cross over from one test to another. So once you have a setup that works for you for throughput, for example, you can use that same setup for packet loss test and other things. So we'll start here doing a throughput test. First thing we'll do is connect to the chassis. Now you'll notice there are 4 buttons down the left hand side. We're going to work our way down that list of buttons, setting up first ports, then clients, then the test, then the mapping. So the first thing we're going to do is connect our laptop that we're running on here, which is where the WaveApps application is, to the chassis. If we are connected directly to the chassis, and the chassis is not connected to a network, then the chassis will have come up and defaulted to 192.168.1.1. That, of course, assumes that we have our laptop or our PC also set to static IP addressing in the same address range, but not 1.1. It'd be a 1.10 or something of that nature. But I'm actually connected to a live network, and so the host name of the chassis, WTTGA0032, the last 4 digits of the MAC address of the management blade, will get us to our chassis. So now what we connect to the chassis, and what we see is the application will show us the 2 cards that are in that chassis for us to use. If the chassis had more cards in it, they would just show up here in this list. But we're only going to need 2 cards. One is an Ethernet card, an 802.3 card, and the other is a wireless card, 802.11. You associate these ports, these cards, with the test by checking the box next to them. And you can see that as we highlight a card, information about that port is now displayed over here on the right hand side. For the .3 card, we can leave that at all default. For the .11 card, the only thing we really need to tell that card about our test is what channel to set to, because it's connected to a specific access point. The easiest way to do that is to just press the Scan Channels button. Now you notice that what's happening is that card is going out and scanning all of the channels and looking for activity on one of those bands. As soon as it finds beacons on a particular channel, it's going to stop there after telling us what are the beacons that it found. So you notice that it just stopped on channel 136, 5 gig band, and it shows us an access point that is broadcasting 4 different networks, 4 different SSIDs, and here are the BSSIDs associated with those 4 networks and the power level that the card is picking up in its cabled up configuration. So the test will use this information later on once we set up the clients. If we know what the channel is that the access point is already tuned to, we can just come in here and put those numbers in directly. Next, we'll set up clients. The concept here is that you have a client group, and all the clients in that group will be identical to one another except for their MAC address and their IP address. And this gives you the ability to set up a very large group of clients, all of which have the same characteristics, and to set up many different groups of clients if you want. But in the most basic situation, we need to have a Wi-Fi client group and an Ethernet client group. So let's set up a Wi-Fi client group first. We're going to give it an arbitrary name of Wi-Fi. Now, the IP address could be set up as a static IP address. We're going to enable the client group to get its IP address from a DHCP server in this network. So these will be ignored, and it'll go off and get IP address from the DHCP server. We need to describe what type of interface this group requires, and it could be an ABG group, a legacy group, an 802.11n group, or an Ethernet group. In this case, this is going to be the 802.11 client group. Since there's only one port in our chassis of that type, it fills that in for us. But then at that port, if you remember from the ports page, we saw 4 different SSIDs. So we have to describe to the test which SSID should this client group be associated with. And we're going to use open. Now, while we have this line highlighted, you'll see at the bottom of the page we can set up other characteristics about this client group. For example, we can choose what security type this client group would connect up with. Now we're going to choose open just for convenience here. We can also choose whether this is a legacy B, a legacy AG, or an 802.11n client group. We're going to choose N. We're going to make it a short guard interval, 40 megahertz. We'll turn on aggregation, and we're going to set the transmit power to about -15 because we have a 30 dB attenuator in the RF cabling between the wave blade and the access point. And by us transmitting our client power at -15, that means the access point is going to see signal power around -45, which does not overpower the receiver of the access point. You can see that the phi rate we've set up for here is about a 300 megabit phi rate. And the next thing we will do is set up the Ethernet group so that we have a traffic group defined on both an Ethernet card and a Wi-Fi card, so that we can do an end-to-end test. So with an Ethernet group, we're going to set him up to be DHCP as well, and again it could be static IP addressing. We would just need to make sure that we put in IP addresses that don't interfere with one another. The interface should be Ethernet. It fills in the card that's available to us, and of course no SSID. With the client information down below, if there was security that needed to be turned on, we could do that. And under the advanced options, we could set up VLAN tagging and other options if so desired. But we're going to leave everything at the default, which means that it'll go out and get its IP address for both the Ethernet and the Wi-Fi clients. It'll assign the Ethernet clients to this port card, the Wi-Fi clients to that port card, and we set it up to be only one client of each type. We could change this number to 500 if we wanted. Easily we could make it 20 Wi-Fi clients, which is one of the strengths of the VariWave solution. But for simplicity, we're going to leave it at 1. Now we go and we set up the test. I'm going to shorten the test parameters here. So the trial duration just says how long does traffic run before it stops and a measurement is made. So we're going to set it to 5 seconds just to keep things shorter, but you might want to leave yours to 10 seconds or longer. We're going to set up the loss tolerance to be 0.1% because that's what's appropriate for the Wi-Fi side. There are other things that could be set up here in terms of choosing your traffic type, setting your ports, changing your traffic payload, setting up QoS, and altering the client connection process. For very large situations, you may want to change the client connection so that the test doesn't outrun the access point itself. Under advanced test parameters, this is where we can enter information that will be a part of the report that comes out later, so that we can list the AP model and software version, things of that nature. We can also set up a log directory. When we run the test, the results that come from the test plus the configuration file are all stored into a directory for later access. That's what this directory is. Now we're going to go over here to the Throughput Properties tab, and this is specific to the throughput test. Every one of the application suites has its own tab specific to the type of test that's being done. But here we're setting up the throughput properties. So the way a throughput test works is for each frame length that is selected, it does a binary search starting from the starting point, which you can set, and moving towards the maximum until it finds the maximum forwarding rate at which the loss is less than this loss tolerance set here. So in our case, we're going to run traffic for 5 seconds at a particular load. The test is going to go out and pull statistics off the cards and determine if the loss was 0.1% or greater. If it was not, it'll increase the load to a higher level and try again. If it did detect loss, it'll decrease the load, and it keeps doing this in a binary search pattern until it finally finds the maximum forwarding rate at which the loss is acceptable. So we're going to start at a 50% load, and we'll work our way up if we pass, and we'll work our way down if we fail. The last thing, well actually before then, I'm going to shorten this test to only do one frame size just to keep the test time a little bit shorter. You could enter a long list of frame sizes if you want. You can set it up to increment through a variety of different frame lengths if you desire. We're just going to choose one. Under mapping, now we get to choose whether it's a downstream test, Ethernet to wireless, whether the traffic will be upstream, wireless to Ethernet, that's what we're going to choose, and whether we send bidirectional traffic or unidirectional traffic. Now we're done, we're ready to run. We just come up here and press this green button. The test goes out, connects to the chassis, sets up the clients. You can see them doing DHCP handshakes here. And this dialog that comes to the screen tells us the progress that we're making as we go through the test. So you notice that it went through an ARP exchange, and now it's driving 10,900 packets, which is 50% of the IEEE load in the upstream direction. You notice that it passed that, it saw no loss, so now it's going to a higher load. It went from 10,000 now to 21,000. It passed that as well. A little bit of loss, but still less than that 0.1, so it's going to go to a higher level of load. So now we are pushing above 100% is what we're attempting to push through that access point until we find loss, or until it goes to 150%, which was the maximum we had set up, or it gets to the place where it's within 1% of the theoretical max. So it's just going to keep stepping up, running 5 seconds worth of traffic because that's what we set for the iteration, and every time it completes that, it harvests information off of the cards and can tell what the exact frame loss is. So now we're seeing that we're getting kind of to the end of our test. We're still getting zero loss in the upstream direction, which we should get zero loss in the upstream direction, because 802.11, if there's any retries or any throttling, then we should be seeing the 802.11 protocol take care of that for us. Alright, now we're completed with this test, and here we get a PDF report printed to the screen and also saved in the file folder that I mentioned earlier. So as we scroll down, we'll get our answer here. We see that the throughput number that we got was 238 megabits per second, and these are the configuration variables for the test. We see that we were transmitting 5 seconds on each iteration, what the settle and aging time for each one of those were, what the acceptable loss was. We said it was 0.1%. These are the search algorithm characteristics. This is a topology map that shows that we were running upstream for that traffic. And now when we get down into this level, we see that the detailed results for 1518 byte frames, theoretical would have been 265 megabits a second. We scored 238 megabits per second. We were connected to CData and Open at minus 23 dBm. This is the min, max, and average RSSI we saw over the course of the test, and we were on channel 136 connected to this BSSID. Right, so that gives us an example of how much time and what the setup is involved with getting a throughput test. Now, we just ran with one wireless client, one Ethernet client. It would be very easy for us to go back to setup, go over to clients, and increase the number of clients that were running that test to, say, 64 or 65. If your access point can handle 64 wireless clients, the way that you now run a throughput test with 64 clients is just change this number and then go back and hit the green button and you're off and running. So that's how easy it is to both get set up and also make changes so that you're scaling the test in the dimension you want. If you want to run a test that has diversity of clients, let's say we wanted to run one Wi-Fi client that was an 802.11n, remember we set this up as a MCS 15 client, it would be that easy to just come in here and say, well, let's set up a CISO client. Let's let that client be DHCP enabled also. But now we are going to select perhaps an MCS rate of 7 if we wanted that to be a single spatial stream, maybe 20 megahertz. And if we wanted that client to be appearing further away from the access point, maybe we put his transmit power at -25. So you can define a long list of individual client groups and each client group is uniquely identified, but all of those clients then will run on the media at the same time. If we wanted to run a different type of test, so let's say we ran a throughput test but wanted to move to a packet loss test instead, as we do the test configuration, you'll see that the information that we've already set up for the chassis and already set up for the clients remains as we move back and forth between tests. The only thing that changes is that on the test tab, those characteristics particular to that specific test. So if we were running a frame loss test, it wouldn't be a binary search anymore. We might want to run a 1518 byte frame test and run it at just one particular load, 23,000 frames a second, let's say, and maybe we want to run that Ethernet to wireless. Then when we press the green button, all of the things that didn't change from the earlier test are kept the same, and we're now running a frame loss test. One last thing that I'll point out here is as you run these tests, you can choose by going to the options button to save the hardware logs after a test. So every packet that is sent by one of our cards and received by one of our cards is stored into a capture log, and that becomes the hardware log. So one way of getting a quick look at what's going on in the wireless domain, for example, is aggregation working correctly, do I have a lot of retries, would be to come run a packet loss test, set that test to be very short, let's say maybe only 3 seconds, and turn on save hardware logs. Now when you run the test, in the file folder that we pointed to here under advanced test parameters, the one pointed out here, there will be files called VWR files, they're log files. That'll be all the packet captures done, so now you can do a packet inspection of the transactions that happen between the access point and the wireless card, or on the Ethernet side as well. So this concludes this video that gives you a quick look at how you can set up to run a throughput, packet loss, any of the benchmark tests, and get them up and running and get your results.